So for this video, we are looking at continuing on our um, problems that we're working on from our purple handout. So we're continuing to work for 4.1 and we're continuing down our problems. We did number 8 on the last part, so on this part we are starting with number 9. So when we look at number 9, we're looking to see how long it will take 5,000 to grow to 6,500 if earning 12% compounded monthly. So we want to pull those apart and see what our values are. So in this case, we have 5,000 is going to be our P. 6,500 will be our A. It's going to be our accumulated value. Our R is 12%. Remember, we need to write that as a decimal. And we're being compounded monthly, so monthly is going to be n equal to 12. If you were not here in class on Wednesday, those values can be found over here for how many times a year. All right, so we're looking to use one of our formulas that has all of these values, and we're looking for how long. So we are trying to find what t equals. So we're going to use our formula of A equals P times 1 plus R over N raised to the NT. And now we're just going to plug in our values. So our A is 6,500 is equal to 5,000 times 1 plus 0.12 divided by our N, which is 12, raised to our N, which is 12, times T. And anytime we end up with our variable up in our exponent, we know we're going to end up doing our natural logs. So I'm going to start out by dividing the 5,000. We're going to divide by 5,000 on both sides. And again, remember, you can cancel out double zeros there. So we are looking to 65 divided by 50. So we could reduce that down to divided by 5, and we could reduce it to 13 divided by 10. So 13 divided by 10 is going to be equal to 1 plus 0.12 divided by 12 raised to the 12t. So now what we're going to do is take the natural log of both sides. So we're going to get the ln of 13 over 10 is equal to the ln of 1 plus 0.12 over 12 raised to the 12t. So now we can bring our exponent out front. So we have the ln of 13 over 10 is equal to 12t times the natural log of 1 plus 0.12 divided by 12. Now, to solve for t, we need to divide by everything that is not. We're dividing by everything that isn't t on both sides. So I'm going to divide by 12 times the ln of 1 plus 0.12 divided by 12. And I'm going to also divide this over here. So 12 times the natural log of 1 plus 0.12 divided by 12. All right, so that tells me, so everything's going to cancel, that my t is equal to the ln of 13 over 10 divided by 12 times the ln of 1 plus 0.12 divided by 12. So that's going to tell me that my t is approximately equal to 2.197. Okay, so the next problem we're looking at is how long to double the investment of 2,000. So when we're pulling out our values for this one, our initial value is 2,000. So that's what P is going to be equal to. P is equal to 2,000. It earns 9%, so that's our rate is equal to 0.09. We have compounded monthly, so that tells me that N is equal to 12. And because we're looking at doubling the investment, that tells me that the accumulated value will be equal to 2 times 2,000, which will equal 4,000. And T is the how long, so we're trying to figure out how long it will take. All right, so because we have an N and we have all our other parts, we are going to use our A is equal to P times 1 plus R over N raised to the N times T. So our accumulated value is going to be 4,000 is equal to 2,000 times 1 plus 0.09 divided by 12 raised to the 12 times T. First thing I'm going to do is divide by my 2,000. So again, those zeros will cancel. And 4 divided by 2 will equal to 2. So we have 2 is equal to 1 plus 0.09 divided by 12 raised to the 12t. So again, we have t in our exponent, so we are going to do the natural log of both sides. So the ln of 2 equals the ln of 1 plus 0.09 divided by 12 raised to the 12t. This allows us to bring our exponent out front. So we'll have the ln of 2 equals 12t times 1 plus, the ln, 12t times the ln of 1 plus 0.09 divided by 12. So now we're going to divide by everything that is not t. So it's going to be 12 ln 1 plus 0.09 divided by 12 on both sides. So 12 ln 1 plus 0.09 divided by 12. So now that tells us that t is equal to the ln of 2 divided by 12 times the n of 1 plus 0.09 divided by 12, which, when we plug the values in, will tell us that it is about 7.73. Our next problem we're looking at is how long it will take 6,000 to grow to 7,000 if it earns 7.5% compounded continuously. So again, we're looking to see what do we have and where we what can we do with that. So if we look at 6,000, that's what we're starting with, so that's going to be our P. 7,000 is our accumulated value because that's where we're growing to. 7.5%, that's going to be our rate, so that would be 7.5, so that's going to become 0.0075. Just 1 0. It'll be 0.075, just 1. 0.075. And our t is what we're looking for. T is equal to how long? It's compounded continuously, so when it's continuously, we do not have an n, and we're using our A is equal to PE to the RT. So now we're just plugging in our values. So 7,000 equals 6,000 times E to the 0.075 times T. So we're going to divide by 6,000. So that'll get us 7 over 6 is equal to E to the 0.075t. Taking the natural log of both sides tells us that we are going to have the ln of 7 over 6 is equal to, we will bring that out front, 0.075t. Now remember, our ln and our e undo each other. So they're going to cancel out. So that is going to leave us with this portion. And now all we have to do at the very end is divide by everything that's not t, so 0.075. So our t is equal to the ln of 7 over 6 divided by 0.075. When we plug that in, our t, into our calculator, our t is going to be equal to approximately 2.05 years.